Illinois State University. Everybody welcome, I'm glad you're here. What I'd like to do is I'd like you to join me in presenting Toyota Business Practices, Engineering Report, Urethane Bead and Plant Production Issues. Alrighty, what's going on here? What we're going to do is going to clarify the problem. The ultimate goal is to significantly reduce the number of production line errors, that is, produce countermeasures for and-in pools. That's when you have to stop the factory from working and the factory line working, and excessive muda, that is mess, from unbalanced adhesive urethane bead width problems associated with the plant 2 observed over the past 7 months. All right, the current situation is that Camry, Venza, and Avalon have windshield issues concerning how the windshield is applied to the cars, specifically this urethane bead adhesion and the strength of the seal, which is very, very important. For the one Venza, specified urethane weight is 0.9 to 1.0 kilograms per car, and 2, the Camry and Avalon 3, urethane weight is 0.7 to 0.8 kilograms per car. The proper bead shape would be an isosceles triangle, 8.0 millimeters wide at the base by 12 millimeters height. The ideal situation would be safety issues concerning correct weights, dimensions, ensuring proper adhesion to vehicle, appearance issues concerning the fact that the urethane is out of sight of this for aesthetics. In other words, you can't see it, but it sort of does reflect upon the aesthetics, as you will see later in the report, and cost to waste issues concerning minimizing the waste cost per weight and dimension. All right, so let's break down the problem with a process or a process flow or a SciPop diagram. We're going to look at the suppliers, the input, the process, the output, and the customers. Suppliers would be the metal company, the glass company, urethane company, and rubber company. What do they supply? They supply the input, the metal, the glass, the urethane, and the rubber. The process is how we cook it all up. It's like a recipe. Applying the windshield to the window frame via urethane chemical. All right, so apply the body primer first, allow the air to cure, then assemble glass into the cavity. Then coat the glass primer, clean by hand, load the glass, and then finally prime, dry, check, add bead of urethane, and pressed onto the body. So you can sort of see that process going on. Our target setting will be a bead width design dimension. Our target bead width design dimensions would be 5 millimeters to 11 millimeters wide, and with a tolerance of 8 millimeters. To do a root cause analysis, let's see what's going on. What could possibly be happening? Okay, we're going to use a fishbone diagram to do that. There are 4 different areas of problem. There'll be the man, the method, the material, and the machine. All right, for human error, it could be misset, mishandled, not cleaned, new employee, all right, and misoriented. For the method, it could be incorrect temperature, incorrect angle, incorrect pressure, incorrect timing, or inadequate cure time. For the material, incorrect amount, incorrect material, incorrect viscosity, shelf life exceeded, and pump wear. For the machine, incorrect part loose, electric short somewhere, wrong assembly, or nozzle wear. 5 whys, famous 5 whys. Why do we do this? No pun intended. The 5 whys pertain to asking why 5 times pertaining to a particular short falling event or something went wrong, so as to answer why the difficulty occurred. Thus, in relation to the bead width problems, you could start with, well, what made the bead of its size too small, or too large or too small? Secondly, what was the problem with the nozzle? Third, was there an error in nozzle design to begin with? Number 4, was there a human error in calibrating the equipment? Well, 5, was there a computer error in dispensing the urethane? The point is to drill down the line of possibilities until an error that is responsible for the other errors is eliminated, thus eliminating subsequent errors. Another source of concern might be windshield placement. Thus, 5 questions associated with them would be, was there an error in choice of windshield? May have been the wrong design. Who was responsible for selecting this particular windshield? Was the proper material selected? Was the correct glass selected for this particular position? Because the front windshield is different from the rear windshield. Was there a problem with the mechanical placement device? Was there a computer generated or position feedback problem? Because in these systems, that's what they use, computers to get feedback. This investigative method was developed in Toyota in the 1950s by Taiichi Ohno for Toyota's production line. It greatly improved the quality and the efficiency of the products manufactured. An affinity diagram would give us a chance to get our thoughts ordered. All right, the 4 areas that would be related to each other would be production problems, company solutions, personnel training, and improvements. Looking at production problems, there's obviously urethane drop consistency, the equipment alignment, and the environmental temperature. For company solutions to these problems, replace or improve the equipment, record errors in performance, and change materials. Personnel training, that is, would involve train persons for specific tasks. That could not be emphasized more. Increase team members or decrease team members, but definitely specialize the training of the team members to suit the job. Improvements. Operating efficiency would have to be improved, equipment control would be improved, and drop accuracy would have to be improved. All right, next we'll do an FME, or error analysis. The FME is designed to systematically analyze potential failures and identify their effect, right? So there are several different categories. This list is actually bigger than it appears. Right, and the way it is scored is from severe, likely, detectable, and then finally gives you a risk priority number. All right, the categories that are shown here are the apply the body primer, allow air to cure, load glass onto the cavity, all right? And there were several others, but it was loading glass onto the cavity that actually produced the highest RPM. Now the question is, how do we lower that number? In order to lower the error due to mechanical positioning instability, given a RPM of 486, one would need to record the minute, that is small errors in positioning over a period of time, and then decide, number one, whether to improve the mechanical equipment or to improve the computer program and thus the process itself. Either would be Kaizen, all right? And it would actually be an improvement that would be visible, you'd be able to see. A team would be designated to collect the data and refine the improvement over time. All right, so data was in fact collected. So let's take a look at the data. It was collected from January to July, okay? And it was collected with regard to the Plant 1 Camry, Plant 1 Avalon, Plant 2 Camry, and Plant 2 Avalon. Right, and what was the information that was gathered? It was the urethane adhesive usage, all right? In this case, it's been converted to kilograms. The urethane adhesive solid waste, all right? And this data begins to show us, all right, that this is the amount of urethane total used, all right? And this is the amount of total wasted. Subtracting the two, you get the waste per month. All right, you get the waste per month in this case. We also get the air emissions, which is very important as well. All right, so, and the waste per month. This is carried over from the previous string. All right, what we also want to do is we want to take a look at a set of graphs. All right, the urethane adhesive usage versus urethane adhesive solid waste with regard to plant 2, since this is where the problem seems to be happening. The graphs above come from the plots of the data that we had seen. There is a very likely relationship between plant 2 urethane usage, Camry usage in particular, with regard to the Camry, and the adhesive solid waste with regard to that Camry. There's also a loosely linear relationship between the Camry urethane usage and the Camry model production. So this is to say that the more cars that you produce, the more waste you're going to get. And there seems to be a linear relationship, although this one is less linear than this one, between the two. All right, so then we do an R chart. All right? The R chart and the X bar chart. These tell us about this. These are used basically in order to give the stability of a plant over time, right? Or to indicate, just exactly as in this case, where trends happen to take place in peak with regard to the mean, in this case. All right, lean management principles. All right, there are 5 different lean management principles. Sorting, which is CRE, which has to do with tidiness. 2 is straightening, which is CTON, which is orderliness. 3 is shining, or sisal. Cleaning, or as we know as pokioki. 4 is standardizing, which is saiketsu. 5 is sustaining, which is shisuki, which is discipline. What is all this to say? What we're trying to do is we're trying to get rid of excess junk. We want to make a safe working environment, right? Organized to reduce waste, and so it's a just-in-time environment. The environment only produces just enough for us to actually be able to use what we want. Therefore, getting rid of excess water, excess waste, and therefore make sure we don't have to stop unnecessarily. Kaizen is a term that means improvement, right? And Kaizen Blitz is when you improve consistently or rapidly over time. Also, a concern for us would be Tim Woods, or the elimination of waste. The key terms are overproduction, inventory, motion, defects, overprocessing, waiting, and transportation. These are the areas where we would actually end up owing to the problem that we had, that we talked about from the very beginning. All right, so let's go through this month by month to see exactly what happened. By January, company performed an overhaul, right? It's Kaizen improvement of urethane robot line 2, and thus the principles of tidiness, straightening, sustaining, discipline were used, stabilizing the process. In terms of Tim Woods, waste elimination, tidiness, and straightening such that no movement or extra material is wasted. In February, company added new hires, right? Form of Kaizen improvement having to do with cleaning that utilizes the principles of tidiness, standardizing, sustaining discipline via training that they received. Robot speed readings were also performed, a form of principle 2, that is orderliness and sustaining discipline. Tim Woods was also used here also in terms of tidiness and orderliness, such that no movements from the robot were unaccounted for. So that actually is becoming a very important thing, how the arms of the robot were actually programmed. In March, measurements were also taken, the bead widths and pump measures involving principles 2, that is orderliness and discipline. So we see these principles over and over again. All right, so the control chart allows a company's performance over time to be analyzed by combining performance data average, range, and standard deviation. In this case, this is the bar chart. And as you can see, it's well within the boundaries, all right? But it gets to be more unstable as we go toward the end. All right, April, equipment status was recorded, as well as pump pressures and urethane average tip height, involving principle 2, orderliness and discipline. By May, June, In addition to equipment adjustments, that is sorting, tidiness, and straightening and orderliness, long-planned process improvement occurred to improve efficiency and hopefully lower the amount needed to spend, that is lowering cost. New heating cooling equipment was installed related to urethane production application factors, as well as a new motor and a particular robot system involving principles 4 that's standardizing and 5 sustaining this. Right? And here we have a R chart for that particular one to explain the stability. And it is also well within its measures. By July, in the month of July, the improvement to equipment was tested, indicating improved efficiency and a reduction in waste. Tim Woods was obviously a consideration in all of the above procedures. For the future, all right, I tend to go in the direction of Darwin's dimensions of quality that Toyota would have to use. That is performance. Invest in teamwork, so that you have many eyes toward the final product performance. You would want to improve the features associated with the windshield design, that is urethane, glass windshield, metallic surfaces, interlocking nuts, bolts, and screws. Right, all of these components put together meticulously, right, to make the features of the vehicle better. Reliability, combining skills, right, improvement team, creates a lean-based environment. Again, that word teamwork comes in. Factory line doesn't have to be shut down, and bead sizes meet the required standard. Conformance to industry standards would immediately be covered, all right, and durability of the product would be ensured to be better than the previous designs. Without question, the car itself would benefit from a serviceability perspective due to the fact that the parts would be of superior quality. Aesthetics, getting to that issue, the car would benefit from an overall improved feel to the driver and passengers from the component parts and materials being installed in a better way. Perceived quality, Toyota's reputation would improve. When the work and attention to detail publicly known, improving windshield construction process would improve the entire vehicle construction from the perspective of the buyer. So to sum it all up, continue to document the measurements, improvements, Kaizen process, and invest in newer, better, precise devices for urethane distribution to lower application error. Thank you.